Good morning, everyone.
Good morning.
Good morning.
Good morning.
Good to see you again. We're almost done. It's the last week. We have this lecture and tomorrow's lecture left, and then we're done with the course. That's insane. It went fast, faster than I expected in this online form. Today we're going to be talking about mediation analysis. And as I told you earlier during this block, at the start of this block, that this entire block is mostly focused on regression analysis, on using regression analysis to see if you can come up with a predictive model where you have continuous variables predicting some other continuous variable. And we've seen that, we've started with the basic simple regression and progressed from there. And the mediation analysis is no different than that, where you could assume that because it has a different name, it's called mediation, that it's something entirely different. But as I hope you will see during the course of this lecture, that it's just using regression models to determine if there is a mediation effect within your model in your experiment. So we'll be diving into this today, and so the topics for today are as follows. We're going to look at what is mediation analysis. We're going to simulate some data and apply it. And what I want to do, because if you already started with the weekly assignment, you will see that the mediation analysis is done by using this add-on for SPSS called Process, and that Process provides you essentially with all the information that you need to perform this analysis. But what I want to do is to show you that even with running simple regression models in SPSS, you can get to the same kinds of results, and that the process package is essentially to make the analysis a bit more convenient than by running it as different models in SPSS. So we'll be looking into that, and we will have a look at the different effect measures of mediation. We'll cover a few, and as you will see, the process package is continually under development, and what that means is that sometimes due to how can I say this, gained insight, some analysis have been dropped from the process package. So where fields in the publishing cycle is still a few years behind, the process package already updated their analysis. So there are some analysis that are explained in fields that the process package can do, which it cannot anymore. But we'll look into that, and we'll cover a few. Okay, so mediation analysis. So with the mediation analysis, you try to determine if an effect of a predictor model is mediated by some other factor. So in statistics, the mediation model is one that seeks to identify and explain the mechanism or process that underlies the observed relation between the independent variable and the dependent variable. And through the inclusion of a third, we'll call it a hypothetical variable, and we call this a mediator. But it's it's just a predictive variable. So if you look at the way that SPSS is structured, the columns that you have where you have a predictor variable and another predictor variable and an outcome variable as a column, that doesn't change. So the fact that we call it a mediator is not that it is some mystical thing that's going on. It's just another predictor. But in the way that you use these regression analysis in determining the mediation, it is a way to essentially model the path of the relationship. So it is often said in a bit of a layman's terms that one affects one thing and the other affects the next. So instead of having a direct relationship, the relationship on the outcome variable goes through this other variable. And one thing I do want to mention right off the bat is that you have to be careful with attributing causality to this relation, because as it states here in the slides, it's that it seeks to explain the mechanism or the process, and this mechanism and process, if you think of this in a causality from a causality stance, then you would really think that one influences the other and then it influences the outcome variable. And that could be the case, but if we only have measured observations of predictor variables, then, well, you can't assign causality, right? So is there anyone who can think how you could assign causality, or how you could... What does causality mean in essence? Anyone want to try?
Well, isn't it like, could you not determine the causality if you create an experimental design and you manipulate the independent variable?
Yeah, so you're saying, well, there's one important point, right? That you manipulate the situation, and so that could be the case. But what is the thing that makes it causal, right?
Aren't there three things that make things causal?
Go ahead.
Priority, consistency, and
exclusivity.
Exclusivity. Thank you.
And what do you mean with the priority part?
That X, for example, must precede Y.
Exactly. Yeah. So there's a time a time factor in the effects that precede and proceed the events that happen, right? And so if you think about that process, then looking at a model like this and only determining such a model based on predictor variables, that in essence is not enough, right? So you can say, oh, the path goes like this, but if there's no timely factor involved in that one really leads to the next, then, well, then it's not really causal, right? And that is a bit of a problematic thing with this mediation analysis, because you can just run the mediation analysis on any variable that you have. So if I would provide you a questionnaire and ask you two predictive variables, shoe size and age and intelligence, I could run a mediation analysis which would say, well, the the shoe size is mediated by age and leads to higher intelligence. I could do that, but it makes no sense. So you really have to think about your experimental design and how you can determine this factor of time into the predictive process. And one of the problems, of course, is that if this factor is not taken into consideration and people run such a mediation analysis, and then in the attribution of the results really go to the explaining part, to trying to convince the reader that there's not a direct effect, but it's an indirect effect, and that one causes the other, and then you see this outcome, that would be a false claim. So you really have to look at more than just a regression model to make any of these causal inference claims. So that's very, very, very good observation. So we're gonna look on at this model on how to perform this mediation analysis, and what is meant with these steps that you would have to take. So looking at it a bit closer, you see that the independent variable can have a direct effect on the dependent variable, or it can be mediated from the independent variable to the mediator variable, going through the dependent the outcome variable in essence. So mediation analysis is about seeing if this relationship, this one, is stronger than this one. And that sounds a bit vague. So we have to try to see what we need to do to operationalize this, the strength of this effect. And what we'll see is that by running a different regression analysis, we can actually assign the beta coefficients of our regression model to these paths, and that is essentially what is done with the mediation analysis. So for our example, we're going to be looking at the speed of recovery after sickness, if it improves with use of alternative medicine, or if this effect is mediated by a healthy lifestyle. So people use homeopathic medicine, alternative medicine, and claim that this helps improve their health in general, and well, we could operationalize that in some way by the speed of recovery. But well, if I go to the alternative food shop, for example, the people that are there, they all look very healthy, and would try to is it the use of this alternative medicine that they are healthy, that they recover more quickly, or do they have a healthy lifestyle in general, more so than other people? So we're going to try to use this example, and of course this is a fictional example, to see if we can determine if there is a mediating effect by the healthy lifestyle. So we try to predict the speed of recovery, and we have the alternative medicine as the predictor variable, and we have the healthy lifestyle as the mediator. So this is I think the most important slide for you to study, because it shows the relation that we have here the mediation path, it shows how it is related to the regression models. So we're gonna look at this this closely. And what we see here is that with a normal regression where you don't take a mediator or, well, any other covariate into account, then you can have a prediction of the outcome. So you can predict the outcome based on one predictor. So in terms of a regression model, you predict the outcome, and that's why there's a hat on it. It's a predicted outcome, which is determined by a regression model where we have the intercept be 0 plus the coefficient or the weight that we apply to the predictor variable. So in terms of operationalizing these the effects of the predictor on the outcome, you see here that this C that we use here, maybe I can zoom in, this C, that actually is the beta coefficient of the regression model. Does that make sense?
Yep. Yes.
Very good. Now, this is a simple regression, just like the one we did 2 weeks ago. But now we're adding the mediator, and as you can see, there are a few steps being done. So first off, we have the outcome that is predicted by the mediator and the predictor variable. So in terms of a regression model, this is exactly the same as performing a multiple regression with 2 predictors. Only one predictor is, well, the predictor that we use here, and the other is the mediator. And again, it's only a label that makes it the mediator. It's just another variable in our model. So if we look at this, then we have the C, this one, accent, and we have a part of the path B. So in terms of regression model, if you want to predict the outcome based on 2 variables, the predictor and the mediator, then this is just multiple regression with 2 of these variables in them. So what we're seeing here is exactly this regression model. So we can predict our outcome, but this time we have of course the predictor in our model, but we also have the mediator in our model. And both the predictor and the mediator, they both have their own slope, their intercept. So we have a B for the predictor, and we have a B for the mediator. And these 2 are related to these paths. So we have the predictor and the weight that the predictor has on predicting the outcome. So this C accent, and that is the one that we find here. So I also call it BC accent. And the other one is from the mediator to the outcome variable, which we call B. And this one is the coefficient or the weight of the mediator, which I call B here. So the only thing that is missing here now is the relation between the predictor and the mediator. So if I want to determine this one, then I actually can just run a simple regression where I predict the mediator by the predictor variable, and that will give me the coefficient, the beta coefficient, the weight of the predictor for predicting the mediator, and this BA is what we determine here. So the path between the predictor and the mediator. Do you see how these are related? Because this is important, right? So looking at this picture, well, okay, it's a bit of a conceptual model of what the relations are, but it's important to know that to know how such a picture is related to the regression models. So is this clear?
Yep.
Yes, thank you.
Very good.
Actually, not really. I have a question. What
No
is if I would want to know the influence only the mediator has on the outcome without the predictor? Would my results, my outcome, be any relevant to my research? I mean, would it maybe say that the predictor variable is not necessarily necessary in order to have an influence on my outcome?
Yes, but so what you're saying is, can I run a regression analysis with only the mediator as a predictor for the outcome, disregarding the rest, right?
Yes.
Yeah, but the thing is, what we've seen last week when we did the multiple regression is that if you run only a mediator or only one predictor variable to predict your outcome, but there actually is some other factor at play, then you will see the influence of that other factor in the relation of one of the predictors with the outcome. So if there's something going on here, and we have both the predictor and the mediator play a part in explaining the outcome, not taking the predictor into consideration when doing your model, then all the effect of the predictor will show in the relation that you find here. And so what we did last week is we run the multiple regression, which will try to fit a regression model which makes sure that one of the predictors is constant while looking at the other. So with the multiple regression, you actually look at the relation of the mediator with the outcome while putting the predictor at 0. So it's essentially turning off the predictor variable and looking only on to the relation of the mediator and the outcome, and vice versa, of course, because the relation of the predictor with the outcome is determined while correcting for the mediator. So if you would take the predictor out, well, you're not actually taking it out, right? Does that make sense? This one is hard to understand, right? Because how can I explain this?
It makes sense. I don't want to confuse last lectures and today's lecture. When we look at the indirect effect and but now I'm not sure whether I'm taking the information from last week's lecture. Indirect effect is the A times B path, but this is not now in the third equation mentioned. It's just the.
No, that's absolutely true. But let's go back one step, because also for the multiple regression, it's very important to understand that you are correcting for the other variable. So if you have two predictors trying to predict an outcome, only by putting them both in the model, you can cancel out the effect of the other. If there is an effect of the other variable, right? So if there is an effect of the other variable and you cancel that out, you can see what is left only for this predictor on the outcome variable. But if both actually have an effect and you don't put this second one into the model, then all of the effect that this one actually has, it will result in the relation that you have on this one with your outcome, because it influences the score of the outcome. So the score of the outcome is determined by the fact that there's some other factor at play. So yeah, I want to keep it at that for now.
Okay, thank you.
So if we're looking at this relation, so the let's say the mediated relation and the simple relation. With the simple relation, you only have one predictor that determines the outcome, or at least predicts the outcome, which is determined by the beta coefficient.
Could I ask?
Of course.
That's the total effect, right?
Sorry? Is
this the total effect?
Yes.
I think so. I call it the simple relation here, but it's the effect when only looking at one predictor determining the outcome. So, well, you can give it other names, but it's more important that you see what it's doing, and the fact that if you look at this thing above here, this one, it determines essentially if there is a mediation path, if the mediator actually is influencing the initial relation, right? Because when we're saying that if we look at the predictor corrected for the mediator, if that relation is lower than when we look at the relation between the predictor directly and the outcome, well, then something is going on. The mediator has some explained variance part in this entire model. So if you would simply look at what the beta coefficient is of this one compared to a multiple regression and look at the beta coefficient of C accent, and you see that C accent is lower, then the mediator is at play. So there actually is a confounding variable, or in this case we call it a mediator variable that is doing something. And in terms of well, describing a path, if you go from the predictor to the mediator to the outcome, then you can define these indirect effects by multiplying the beta coefficient of A, so that's this one, by the beta coefficient of B, and that is this one. So by determining this path, we get the indirect effect.
I have a question.
Of course, go ahead.
You can start if you want. Okay. I have a question about the third formula.
Yeah.
What kind of effect does that show?
The entire formula, this one?
Yeah.
It just shows you a multiple regression. That's it.
Oh, okay.
A multiple regression with two variables. One we call the predictor and the other we call the mediator. And they just get two beta coefficients. That's it.
Okay.
So it's...
Can I also ask a question?
Yeah, of course.
Because there's some confusion in the chat about what the total and what the direct effect is. So I was wondering if you could clarify, according to the graph, which one is the total and which one is the direct effect? If it's C or C accent.
So where do you get the total effect from? Because I'm not showing this in my graph here. So
No, because some people had thought that so C, predictor to outcome, was total, and then C parenthesis was the direct effect, but I'm not sure.
I think it comes from because when you're using
Sorry.
SPSS, when you're using SPSS, it gives you a total effect, a direct effect, and an indirect effect. So
we'll come back to that. We'll come back to that because we're going to run the analysis also in SPSS. So we're going to tie these things together. So just follow along, and if in the end this is not clear yet,
can I just quickly add something to this?
Go ahead.
The total effect in field, it says that it's not visible in this like triangle thing. So there's a direct effect and an indirect effect, but the total effect is not visible in this. So it's not here. Does that make sense? So it's not in the predictor mediator outcome triangle. It's not like.
Yeah. So we'll look at what SPSS comes up with in the results, and we'll also run the process analysis to see in which steps they take this conclusion, and we'll go to there when we follow along in the lecture. Okay. But don't get bogged up by it, right? It's more important that you understand the relations of the predictor on the outcome and what this graph means in terms of regression models.
Sharon, may I just interrupt? The reason I think why there's so many questions about which pathway represents what effect is that we had to perform this in a homework to be handed in last night.
Okay.
And the questions were directly what is the direct effect, what is the indirect effect, what is the total effect.
Yeah.
So we're just trying to see on your little picture which one represents what.
Let's come back to the question at the end of the lecture. Okay?
Yep.
Good. So, okay, we're gonna, because we can now see that there's a relation between the mediation pathways that we have and the regression models. So if I want to simulate these results, then I can determine a few of these predictor variables. So let's use the use of homeopathic remedies, so the alternative medicines. I create a random variable of this that's normally distributed with a mu of 10 and a sigma of 2. And I will create the mediator, where the mediator is the healthy lifestyle, which is determined by the use of homeopathic remedies, and we add some error. So in this simulation, I'm actually simulating the fact that one leads to the other, right? So in terms of the way that my data here is created, I first create a random variable, and my next variable is the healthy lifestyle, which in this model is only determined by the use of homeopathic remedies. And then in the final step, we add, we determine what the speed of healing is by combining both in a model. So we have a few steps that we go through in this simulation. Again, the simulation part is not really that relevant. You don't need to know how that works. But what it ends up with is a data set where we have the speed of healing, the healthy lifestyle, the use of homeopathic remedies for a bunch of people. And we want to see if the speed of healing is, if there's a mediating effect of healthy lifestyle for the use of homeopathic remedies or alternative medicines. Now, what I want to do first is, before we dive into the into process and see what process comes up with, I want to do these steps that we have here, but in SPSS with regression models. Just to show you that the things that Hayes is doing with his process package are actually combinations of regression models, which you can do on your own in SPSS. So we'll have a look at SPSS. I've got the data loaded already. So we have the speed of healing, we have the lifestyle, and we have these homeopathic remedies or alternative medicine. And if we look at, let's say, this one, to determine these beta coefficients, we actually need to run 3 regression models. So we need to run one with the outcome as with the outcome variable and the predictor variable. So if I go to SPSS, what do I need to do to run this regression model? So I'm going to ask you again to run me through this.
Regression, linear.
Yeah, so we'll go to analyze, and regression, and we want to do a linear regression. And now what?
Now put in the interdependent variable as the outcome, so the healing, I think
so the healing is the dependent variable, and which one did we need to have? We needed to have the predictor. So that is the homeopathic. So this one. So in essence, first step, we need to run this this model. So I'm gonna create some outputs, and of course the assumption of general regressions hold as we've seen in the previous lectures. But running this analysis will result in what we have here, the beta coefficients for the use of homeopathic substances for the healing process. So this is the beta coefficient for this one. Now the next step, so we need to run a linear regression again, and this time we wanted to have the predictor variable and the mediator variable. So what do we need to do? I'll reset. The mediator was the lifestyle. And does it go to the dependent or the independent?
Independent.
The
Independent.
Is there someone that does not agree?
Don't we
the dependent one
program?
Yeah, so we're at this one, right? So if we want to predict the mediator by the predictor, then this mediator lifestyle, this one is the mediator, needs to be predicted by the use of homeopathic substances. So it's the other way around. Do you see this?
So this is the A.
It's this one. So
It's
we're
the
now
A. Yeah.
determining the beta coefficient of A. So indeed, it's this one that we want to find at this point. Does it make sense?
Could you please repeat that again? Why it's the other way around?
It's not the other. It is the other way around, as was mentioned a few seconds ago. But we want to predict the mediator by the predictor. So the mediator needs to be the outcome of the dependent, and we want to predict it by the predictor variable. And the predictor variable was the homeopathic substance use, alternative medicine, and we want to use this one as the predictor for the mediator.
Okay, thank you.
Yeah.
Yeah.
So the thing is, if you look at this chart, everything that's on the left side of the equal sign, this is the thing with your regression model that you try to predict, and everything that's on the right side are the predictors that you actually put in there. But now we're changing the names, right? We're calling this one a mediator instead of an outcome variable, but it's still just a variable. So we have the mediator that will be predicted by the homeopathic use. So we're going to run this analysis, the second one, and again we get a beta coefficient where the use of homeopathic substances has a beta coefficient of 1.2, predicts the healthy lifestyle. Can you follow?
Yes.
Yes.
Very good. And in the last step, we want to run a multiple regression where we predict the outcome by the predictor and the mediator. So again, we run a regression, a linear regression model. I'm going to reset. What are we going to do? We need to put which where.
You need one block with the alternative medicine and one with the healthy lifestyle added to the alternative medicine block.
Yes, so you don't have to specify a new block, right? Because you just want a model where the two predictive variables are in there. So one block would suffice. So indeed, you will need to have the healthy lifestyle put in there. So we have the healthy lifestyle that is a predictor in this model. So this is the mediator, right? And we have the homeopathic substance use, which is the predictor in this, and we want to have the speed of healing as the dependent variable. Do you see this relation? We predict this, which is the outcome, the speed of healing, predicted by healthy lifestyle and homeopathic substances, alternative medicine. That's the predictor and the mediator.
But it's in general now just two predictors, right? Because
exactly.
We never specified what. Okay.
Exactly. So that's the thing, right? The fact that we name this the mediator and that we come up with its elaborate scheme to determine the path, they are just variables. So it doesn't have a special thing in the regression model that says, well, this is a mediator, you have to do something special with this. No, it's just a variable, just like any other variable that you have in running a regression analysis. So if we run this model, we will get a regression model which has both healthy lifestyle and homeopathic use as predictors for the speed of healing. And as we've seen in last week's lecture, that the beta coefficients that we find here represent the relation of this variable, homeopathic use, with the outcome variable, the speed of healing, while keeping the lifestyle constant, and vice versa. And we'll see this visually in a sense. So if I were to ask you which one of these beta coefficients represents the C accent,
the combined model, the homeopathic beta coefficient.
Everybody agrees? Is there anyone that does not agree?
Could you repeat the question?
So the C accent, this one, the C accent, which beta coefficient that we just calculated is that C accent? So if I were to ask you what is the value of C accent given these results from SPSS, then which one is it?
Where it says homeo, right? The 1.301.
The 1.301. That it was my question. This is the answer, the same answer as your fellow student gave, and that is absolutely correct. So it's the one, this one. It comes from the regression model where we have both. And it's the one where that is related to the predictor variable. So our predictor variable in our case was the homeopathic use. So this one is 1.3. And can we say that that there's something going on, that the mediator is doing something in terms of, is the beta coefficients of C accent smaller than C?
We have to check, right?
Yeah. So what do we have to look at then?
The beta coefficient from the homeopathic plus. So
Yeah.
the one,
So, and we ran that one as the first one, right? So what do we see here? We see that this one was the first, and we here try to only predict the outcome variable based on the predictor variable, and this one is 4.7.
Can't you also see it in the other graph? Because the other graph, the first model is just homeo and healing, right? Or no?
And you mean this one?
Oh no, never mind.
Yeah.
Because it's lifestyle. Yeah, okay,
Yeah.
got it.
So this one is, the first one is without taking the mediator into consideration. Sorry, this one. But of course, if there is an effect of the mediator, then it will show in such a beta coefficient. And only if we correct for the mediator, we'll know what the relation is of homeopathic substance use with the speed of healing corrected for that other variable. And if we don't take it into consideration and just say, well, is there the relation between these two? Well, our view of what is actually happening is a bit skewed, right? So that is the relation that we find here.
Sorry.
the
Go ahead.
the difference between I mean, we're eyeballing now. We're looking at the value and we're seeing just if the value is larger. But to actually see if the mediator plays a role in the process analysis, there are the confidence intervals that.
Exactly. We'll go to that. But it's.
So eyeballing.
I think it's quite essential to have a clear understanding of which parts of the regression analysis are you using to make these kinds of claims. And of course, this one is an eyeball in the sense, well, I only looking if this is smaller. Of course, the process package tries to essentially test this with bootstrapping, and we'll come into that. But it's important to see what is going on here and which parts are actually used by the process package to determine this.
Yes, thank you.
And
yeah, sorry, a quick question.
Yeah.
What does it mean now that the beta coefficient of C
is smaller? Yeah,
is smaller than the beta coefficient of C?
Yeah. So what would it mean? Do you think if they were the same?
The mediator has no effect.
Exactly. So if it's smaller,
then there is a positive effect of the mediator.
Exactly.
So what would happen if BC oh my gosh, I'm so sorry. Would be bigger than BC without?
That's a good question. I'm not sure how that would be possible. Maybe it could be negative. But this is a hypothetical.
But it will have to be maybe an interaction effect, or
something like that. But even if you add a predictor variable to your model, it explains something. It can't have a negative explanation in the sense that there's only so much variance to explain. So if it would be smaller, then it would mean that it explains more than is even the amount. So yeah, okay. So we'll not go into that because that will fry our minds. Speaking of frying our minds, I think it's good to get coffee before we actually get fried. Do you agree?
Yes.
Yeah, coffee.
Yes.
Okay. We'll start at 10. We're gonna get a cup of coffee and then we'll look at this visually, and that always helps a bit in trying to wrap your mind on what's going on actually. 10 minutes. Let's get a cup of coffee.
Thank you.
You're welcome. We're continuing, but with coffee, and that makes everything better. I don't actually see people with cups of coffee. Maybe you could cheers. Show your coffee. Yeah, very good. Okay. So I promised to try to visualize a few of these steps, because as I said, visualizing always helps to see what's going on, because with a lot of statistics we're looking at numbers, and if we can't relate what that number means to your actual data, then it's quite hard to interpret. So what I'm going to try to do is a plot the first one, and so the relation between the predictor and the outcome, and then the interaction of, sorry, not the interaction, the multiple regression with both the predictor and the mediator in here. So we've simulated our data, we've looked at the data, we've applied the models in SPSS, and we've seen what the values of the beta coefficients were. I've also run the linear models in R. You don't have to, but that gives me the beta coefficient for A. It gives the beta coefficient for B. So we're going from predictor to mediator, and from mediator to outcome. And we have the beta coefficients for C. That's the initial, only the relation between the predictor and the outcome. And we have the C accent, where we look at the relation between the predictor and the outcome while keeping the mediator constant. So if we only look at the first one, you see, so this is plotting the alternative medicine or the homeopathic use to the speed of healing. And what we see here is that what is that relation, and what is the regression line that actually follows from that. And what we see is that the more alternative, the more people use alternative medicine, they heal faster. And we've seen last week that with multiple regression, no, this is not standardized. It's just, you can see that it's not standardized because we see the actual values here. What we've seen that in our last week is that this view of the world, or at least our data set, is essentially flattened, because if there's a different variable, a second variable at play, then you don't see it from this view. So last week we've seen that if you add another predictive variable, then you can also look at this relation in a three-dimensional graph, and that is what I've done here. And what we essentially see is the same kind of graph that we've seen last week, with the in this case our outcome variable on the z-axis, the speed of healing. We have the homeopathic use as our predictor variable, and let's see if we can turn this. And the interface is I told you last week, within my slides it's turning the turning is quite hard to do, but I'll try. The healthy lifestyle, so the mediator is on this axis. So if you look at this graph and look at the graph that I showed you last week, this is just a multiple regression, but now we call one of the predictor variables we call a mediator. But this is what it is essentially doing. And one of the things that I would like you to do is, if I turn this graph, a little bit. No, I have to turn it straight like this, right? Yeah. And I'm going to zoom in. I'm going to put it off on full screen. I'm going to zoom in, and I want you to look at the red dots. Can you see these red dots?
Yes.
Yeah.
Very good. So if you look at these red dots, then you see that the relationship between homeopathic use and healing, these dots are exactly the same as we're seeing here. Do you see that?
Yeah.
Yes.
So
I don't see it. Where?
So you see these red dots, and they go up as the amount of alternative medicines goes up. Then the speed of healing goes up. And here you see the red dots. You see this outlier. This is the same outlier as we have here. And you see that the lines, the red dots, they form quite a steep line going up. You see that?
Yeah,
So,
okay, now I see it.
yeah, very good. It's important to see, so take your time. So if you imagine a regression line running through all these dots, then that actually is this regression line, right? This one that we've plotted here. You see that?
Yeah.
So if you do this and you look at this plot, you are not taking into consideration the mediator, because only if we look at this way without taking the mediator into consideration, then we see that this relation is quite large. The beta coefficient of this line, of, be more specific, this green line, that one is 4.7 or 0.7. What was it? So this is quite a large relation that we see between the predictor variable and the outcome variable, between alternative medicine and the speed of healing. But if we look at this 3D graph, we see that it's the same relation, but if we twist and turn this a bit and look from its side, then we see that, yeah, the red dots go up, but only when we have a high amount of healthy lifestyle. So the dots go to the back here. Is that clear to see? That the dots only go up while healthy lifestyle is high. Can you see that?
Yeah.
So this view of the relation between the alternative medicine and the speed of healing, it's not really the truth, right? Because, yeah, of course we see it like this, but taking the healthy lifestyle into consideration, we see, well, the healthy lifestyle is also at play here. So to determine what the relation is between homeopathic use and the speed of healing while keeping the healthy lifestyle constant, it means that you actually fit a regression model, a regression plane, and that is the green plane that I've shown here, through these two variables. So the green plane is the regression plane for this multiple regression. And what you see is that the relation between homeopathic substance use and the speed of healing, while taking the healthy lifestyle into consideration, that relation is this line. It's the regression plane viewed from this angle, the angle of homeopathic use and speed of healing, this angle. This line is the relation between homeopathic use and speed of healing when we take healthy lifestyle into consideration. And the fact that we call this keeping it constant means that this slope that we see here for the green one, it's the same for every level of healthy lifestyle. So the slope here is the same as the slope here, as it is for the slope here and for the slope here. Do you see that? It's clear to see, right, that this one is at a low value of healthy lifestyle, and as the values progress of healthy lifestyle goes up, we're going to the back of the to the back of the 3D plot, right? Is that clear to see?
Just to make sure I'm not wrong, but if we just look at the cutting point between the one of the blue plates and the green plate, this line would be the regression between healthy lifestyle and alternative medicine without the mediator. And you can also see, like,
no. It is with the mediator taken into consideration, because the fact that this plane is a little bit flatter than this line is because we take the mediator into consideration. We try to fit this plane in such a way that it fits very neatly for all the data points. Also going to the back, and with going to the back I mean using the mediator as a variable. So we have the mediator healthy lifestyle taken into consideration. That's why this plane tries to optimally fit through all these data points. So we have, well, essentially a fairly good regression model, but that results in a relation of the homeopathic use and the speed of healing. Oh, this is so hard to. No, I don't want to go this way. Go back. Go. Yeah, that's it. Okay. Yeah. So that results in this angle being a lot smaller than the angle that you would have if you would not take the healthy lifestyle into consideration. So let's go. I'm trying to get a good angle here. So I've showed you. Come on. I've showed you the relation of the dots for this one. This is if you look only at the red dots and try to fit a line from this angle to there. So it's going from down here to up there. But if you take the alternative, take the mediator into consideration, this is the line what the relationship is. So instead of it being like this, the relation between homeopathic use and speed of healing, it now is like this. It's a bit flatter.
What's that? I'm sorry. Does anyone of you guys know what the German term Steigung is in English?
It increases.
Increases. Well, the slope, I guess.
Yeah. So the slope of the red dots, where if you don't take the mediator into consideration, it will be like this. So I'm using my mouse to point at the direction of the slope. But now we do take that into consideration, and now the slope is like this.
So the different, okay,
so in terms, I'm trying to get it back to the to this one. So if I would ask you to point at the at C accent, the beta coefficient for the predictor, what are you going to point at? What are you going to point at? This slope? Or somewhere in here? What is C accent here?
In the 3D model, the line from the green thing.
Yeah, very good. So it's this one, this line, right?
Yeah.
Very good. So it indeed is the C accent is essentially the corrected relation between the homeopathic use and the speed of healing, while taking the other one into consideration. So this is the corrected beta coefficient when we add some more predictive variables.
So this is basically that we see now that this is less like steep than the other one, which
absolutely
also was seen in the B, that
exactly.
The C thingy is smaller than the other.
Absolutely,
thing.
that
Okay.
absolutely is the case. And so we saw that without taking the mediator into consideration, it was 4 point something, and with taking the mediator into consideration, let's see, we have the exact numbers here, it was 4.7, and with the mediator taking into consideration, so the C accent, it's 1.3. So it goes from a slope, and when I talk about the slope, I actually mean a slope in the sense that it's an angle. It goes from being a fairly steep slope of 4.7 to being 1.3. So it shows you that the mediator is doing something here, because if it weren't, if the mediator wouldn't have any effect, then it wouldn't go up while the values of the mediator go up. The data points wouldn't go up. It just would be flat, of course, because then the mediator wouldn't have any effect. So one more question. If I look at this one again, let's see. If I would ask you, where would you point if we're talking about this one, the beta from B, the mediator, this one?
So it's on the left-hand side, the slope of the green plane, but then on the left-hand side.
Yes,
so the set on the left.
Exactly. So it's the relation, the slope of the mediator, so the healthy lifestyle, with the outcome variable, and so it's exactly it's this slope. While healthy lifestyle goes up, gets higher, the speed of healing also goes up. So this is a same relation. And as I said, because we're doing a multiple regression, the slope here is the same as every level of in this case, the predictor. So this one in the back here is exactly the same slope as the slope that we have here in the front. So the same holds for the mediator in that sense. And I've only added these blue planes to make the lines a bit more visible, right?
So just a question.
Yeah.
If the mediator would not have an effect, if you would look at it from here, then the top left corner of the green plane will be down at the bottom, and the right middle corner will be up at the top. So it would be like if you know what I mean?
Yeah, I know exactly what you mean. So and of course it's not about the regression plane, but it's about the data points, right? So it would mean that you would also have data points at the low spectrum of the at high values of a healthy lifestyle, and you would also have data points at low values of healthy lifestyle at this point. So your data points would essentially be a plane going from low to high at the mediator to low to high, and the high end of the homeopathic use. Exactly.
Right. Yeah.
And that would result in a regression plane that starts here and would go this point would be lower here, and instead of this point being at the bottom right here, it would be also at the top. And that's obvious, right? Because you see that there would be no relation between these two variables, and that will show in such a regression plane. Okay. Does visualizing make it a bit more tangible to follow?
Yes.
Very good.
Sorry, one last question, a bit more practical. Do you think it would be possible to receive some additional practice questions on interpreting the visualization?
Well, not at this point in the course.
Okay.
But we'll take it into consideration for next year.
Okay, thank you.
Okay, so we've seen from this graph that the relation between your predictor and your outcome variable, that the slope goes down as we add a mediator. So this compared to this results in a less steep slope. And in terms of running the mediation analysis, we're actually interested in the indirect effects, which is determined by multiplying A times B. And this, so we're now transitioning from looking at regression planes to doing some tricks with beta coefficients, because we're going to multiply the beta coefficients. And in terms of regression planes and regression lines, we haven't plotted the A, right? Because the A was the relation between the outcome variable, the predictor variable and the mediator. So we haven't visualized that one. But we did calculate it with our regression model, and if we multiply those two, so that is, I'm going up again quite a bit. So if we multiply the A with the B going this route, we get our indirect effect.
And that is C accent, right?
No, this is not C accent. We have C accent, that's this one. That is the relation between the predictor while correcting for the mediator. And the indirect effect is when we multiply A times B. So this is a different path. But let me get to that, because we're going to see something here. What we're going to do is we're going to multiply these beta coefficients. So we're going to multiply A times B. So it's the beta coefficients of the predictor with the mediator, and then we're going to multiply that with the beta coefficients of the mediator with the outcome while correcting for our predictor. And that, if we do that, we get an indirect effect of 3.461192. So that is if people are showing such a graph and going A times B, then that is the path that they take. But if you look at what I've plotted here below, that is the same as when you look at the initial relation that you have between the predictor and the outcome. If you subtract your corrected relation of that two. And I find it generally a bit more, how would you say that? A bit more logical to state that such an indirect effect would be this difference. Because this is a hard one to swallow, right? So you have one regression model and a beta coefficient, and you have another regression model and a beta coefficient, and we have to multiply these two, and oh, well, that is the indirect effect. But it's more intuitively, it's more intuitive if you would say, well, initially, if you don't take the mediator into consideration, then your slope would be this one, going from the bottom to the top here. And if I do take the mediator into consideration, the slope is this one. So if I subtract these two, then what I'm left with is essentially the indirect effect. So we stated earlier that if C accent is lower than C, then we can determine that the mediator is actually doing something. So if we just subtract the corrected beta coefficients from what we had initially, then we know what the mediator actually does.
If the mediator wouldn't do anything, the indirect effect would be zero, right? Then.
Exactly, because it would be the same, and that is what we've shown, the thought experiment that we did a few minutes ago. If these data points would be if you wouldn't have just data points here, but also at the far end here in the back, where you would have high values of healthy lifestyle, if you would also have data points there and up here, then the regression plane would be the same as would be for the initial relation, and it just would mean that the mediator isn't doing something special, something interesting to your effect. So the special and interesting thing here is that while your healthy lifestyle goes up, your speed of healing also goes up. So with a low healthy lifestyle, your speed of healing is low. That's what we see here. A low healthy lifestyle, low speeds of healing. And a high healthy lifestyle, high speeds of the healing. So this is what adds to the explanation. If that weren't the case, well, then subtracting these two or going through the alternative route would result in zero. Does that make sense?
Yeah, but
Yes.
isn't this stating that there could be no possible effect of an unobserved variable, for example, another mediator that we didn't measure?
Oh, that could be. Yeah, sure. Absolutely.
But if we subtract the C from C accent, and in that case, we may not find zero because there could be some other variables that explain.
No, because it tries to fit a model that optimally fits these two variables. It could be that, and you would just have more noise in the model. So, but it could be the case that there actually are multiple pathways, but we're not going into that in this course for now. Okay, so we have our indirect effects, and let's look at what this looks like if we run this analysis within the process package. So if I go back to my data, we have done all the regression analysis. We've determined the beta coefficients. We've seen from these beta coefficients what the indirect effect is, and we will see with when we run the process package, it will give us the indirect effect, but it will also give us some additional standardized versions of these effects, and it will also give us some bootstrapped tests to see to test if this actually is something that is of significance. So we need to go to analyze and then regression, and we're going to use the process package. I'm using SPSS 27, the latest version with the process package I installed yesterday because I haven't used it for a while, and it works, so that's good. So what do we do now? Run me through this.
We have to put the model number on 4, I believe.
Yeah, exactly. So I really appreciate that Hayes created this package for us to use, but it is really, I think, a bit inconvenient to have a model number without any specifications of what this is. So we need 4. Yeah, indeed. Okay, that's good. And now what?
You put your outcome variable in the y variable.
Yeah, so that is the speed of healing. Eh? We put in the y variable, and then
homeo in the x and lifestyle.
Yeah, so we want to predict it with the homeopathic use, and we have the lifestyle as the mediator that we want to use. Okay, any options? Let's see. Any options? So if yeah, go ahead.
Effect size.
Exactly. We need to have show the total effect size. Well, at least we have model 4, so that's something we need. The effect size with the mediation only models is something that we would like to see, and the pairwise contrast of the indirect effect.
Field talks about a Sobel test as well, I believe.
Yeah, the Sobel, I think Hayes killed the Sobel test because I don't see it anymore.
I couldn't find it either.
No, and that's the thing that I said, right? That the process package gets updated quite frequently, and if there is a research paper showing that the Sobel test is not really the best way to do it, then Hayes will just drop it out, and that's what he's done here. He's just dropped the Sobel test from the package to run. So we're not going to do that one. Was it still in the weekly assignment?
It was.
Okay, so I'm going to take that out. So that probably caused.
Oh well, I'm not sure
confusion.
it was in the weekly assignment. It was in the preparatory assignment of the tutorial group.
We'll look into that, but you can skip the Sobel test because we're not able to run it anymore. Okay, so if we run this one, and one thing that is also in the notes by Hayes is that you shouldn't use the paste but use the OK.
The screen. We don't see the screen.
Oh, sorry. Yeah. One thing that Hayes said is not to use the paste, but just run this because it will run a script that will essentially do the entire analysis. So I'm clicking just the OK function here. Is it doing anything?
For me, it took
Yeah,
a
it's very
while
slow.
before printing.
Yeah, indeed.
Yeah, there you go.
Here it is. So, well, first off, we are presented with the results in a little bit simple view of this, just text. But what we're presented with are essentially regression models. So, in terms of regression models, what do we see? The first that we are presented with is the outcome variable is healthy lifestyle, and it's predicted by homeopathic use. This is the same 1.2 as we found earlier in our regression model. So which is this? Is this A, B, C, or C or accent?
It's A, right?
Very good. This is A. It's the relation between the predictor variable and the mediator. So that is the one we have. The second one that we are presented, oh, that's too fast. The second regression analysis that we are presented with is the speed of healing. The outcome variable is the speed of healing, predicted by the homeopathic use and the healthy lifestyle. So is this homeopathic use, this one? Is this A, B, C, or C accent?
Is it C accent?
Anyone?
No, C without an accent?
C without an accent, I hear. I need more input.
It's C accent, I think.
Anyone
C.
agree? Who does not agree?
Is it B?
No, it is C accent. It's the relation between homeopathic use and healing while correcting for the mediator, the healthy lifestyle. So this is the regression, and this is the regression model where you have two predicted variables in there. So here, the first one, you have a regression model with only one predictor, and now you see a regression model with two predictors. So in the same way that we had run our regression in SPSS here, where we predicted the outcome based on these two variables, the predictor and the mediator, homeopathic use and lifestyle, 1.3, 2.8, it's exactly the same. It's just shown to you in a little bit different way. So this is C accent, and this one, lifestyle,
B?
That's B indeed. So this is you need to practice with this to see what those relations are again that we showed in the first slide to what the beta coefficients actually are. The last one, it is predicting healing based on the homeopathic use. Is this A, B, C, or C accent?
C.
Exactly. So we have essentially three regression models that are run here, where the same regression models as I'd run separately in SPSS, and it will give you these beta coefficients that we've been looking for. Okay. So, in terms of total effect, because that was the main scope of the question, right?
Can I ask something? Sorry.
Go ahead.
So I'm a little bit confused now because in the book of field, if you look at the output and then look at figure 11.12 on page 508, the indirect effect is actually A and B multiplied.
Yeah.
So, and then, but the indirect effect is not C accent because That's where my confusion lies. So what is C accent? That's not the direct effect. I thought it's the indirect direct effect, but it's
No.
okay.
You have. Let's see. Go back to this one again. Oh, sorry. Here. You have direct effects.
We can't see the slides.
Oh, sorry. Now you can't. You have the direct effects the simple relation of predictor with the outcomes.
Yeah.
You have C accent, and the indirect effect. Indirect effect is the multiplication of A times B, so it's this path.
Okay.
And that indirect effect is exactly the same as if you were to subtract the C accent from C.
Right. Okay.
A times B is the same as C minus C accent, and that we've shown, I think, here. A times B, the indirect effect, calculate the indirect effect. 3.4 is the same as subtracting C accent from C. You see?
Yes. Okay. Thank you.
Very good.
Sharon?
But yeah, I believe she just called C the direct effect, but C is the total effect.
Yeah. Okay. So if you, and that was the point where I was going for here, because this. Here is where the total effect thingy comes into play. So Hayes calls this the total effect of X on C, which is 4.7. And we can see that 4.7 comes from our model where we try to predict the speed of healing by the homeopathic use. So this total effect is essentially C, the same. So this total effect that Hayes calls and tests here is the same as, well, one too far, it's this one, C, the total effect, which we also sometimes call, or some people call, the simple relation. Does that make it a bit clear?
So C is not the direct effect.
So here we have the direct effect, X on Y. So, well, you tell me, what is what? We have the total effect, which is 4.7, and the direct effect, it's 1.3. So what is the direct effect?
1.3.
C accent.
C accent, right? So, and this is why it's more important to see which parts of the puzzle you are using and then stamping a label on it. So now we've seen all the parts of the puzzle, so you can determine if you see this, that the direct effect, okay, we call this the direct effect, and we see what the value is, 1.3, and where does that come from? It comes from the model where we have both 1.3, it's here, homeopathic use and healthy lifestyle, on predicting the speed of healing. So this 1.3 is actually the C accent. So in terms of the labeling that Hayes uses, total effect is C, direct effect is C accent. And the indirect effect is the multiplication of A times B. And now you have your three parts. Does that clear things up for you? It does for me, because I was confused about the total thing and which was what again, and then I ran the analysis. I see these things and oh, that's what it is again. Does it make sense?
Yeah, it does.
Yeah, it does for me.
Very good. Cool. Well, we're not there yet in the sense that Hayes provides some ways to test these effect sizes. So the first, because these are actually just beta coefficients in a regression model. So that means that within the regression model, it's just tested with a t-test. So the beta coefficient can be zero, or let me state it differently. The null hypothesis for the beta coefficient is that it's zero. So if we test it with a t-test, then we're actually applying a one sample t-test on the beta coefficient. So in this case, the total effect we have 4.7. We can calculate the t-value from that, which we've done in the simple regression analysis 2 weeks ago, and we can simply test if that a t-value of 34 is rare. Yeah, it's absolutely is. So we find a p-value lower than 0.05. So in that sense, we determine that it's the total effect is significant. Yeah, sure. But there's something else going on because we have a mediator that influences the result. So if we take the effect of the mediator out, we still have, in the direct effect, a significant impact. And now we're looking at the next step. Well, because if the mediator does something, it decreases our slope from 0.47 to 1.3, then what is the effect of the mediator? If I take that path of A times B, or in other words, I subtract the direct effect from the total effect, you see this? 3.4 is 4.7 minus 1.3. I get the indirect effect, and is that significant too? And now we have a bit of a problem in let's say the statistical sense, because for beta coefficients we have a clear hypothesis, a null hypothesis to test, because a beta coefficient of 0 is the thing to test to. But now we have subtracted two beta coefficients, and these beta coefficients also have different standard errors. So you can't just say, well, I'll test this new subtracted beta coefficients to the null hypothesis, because we actually have no idea what the estimate is for the standard error for this one. And the thing that is applied in these cases, which Hayes does here, is a so-called bootstrap method. And a bootstrap method, you don't really have to know what the process means and how it works, but essentially it uses your data to take subsamples of your data. For every subsample, it calculates a mean, and does that multiple times to create, in essence, distribution of the means of your sample. And with that as an estimation, you can determine what your bootstrapped standard error is. So what we're looking at here is we see that the bootstrap standard error is calculated, and if we have a bootstrapped standard error, then we can calculate a bootl-C, and we can calculate a boodle-C. What are these? What does it stand for, do you think?
Confidence intervals, right?
Lower limit confidence interval. And the ULC is the upper limit confidence interval. So these are the confidence intervals that we created, but they are the confidence intervals that are created around your test statistic. So our test statistic here is 3.4, and the confidence intervals that are created based on the bootstrap method are around that test statistic. So 2.6 is the lower limit, and 4.2 is the upper limit. So it means that we can be if we replicate this again and again, in 95% of the cases, your actual test statistics, which of course is a point estimate, fall between these lower and upper fall between the lower and upper bounds. So the trick here is that if we know if the null is true, then we would expect a beta coefficient of 0. So if we see that the lower bound, so if we state that this point here is 0, if we see that the lower bound of my confidence interval and my upper bound is here, if the 0 is not included within this interval, then I'm fairly confident that the value that I actually get of my test statistic is not 0. So the thing that you look at here is to see that we have a value, an effect size here of an effect of indirect effect of 3.4 with a lower bound of 2.6. That's still higher than 0, so I can conclude that there's a significant indirect effect. Does that make sense on how to do you see how to interpret this?
Yes.
Good.
Can I ask something quick about this? So let's say the confidence interval will be like 150 to 151. Would that mean you'd be more confident that it's that the null hypothesis that you can reject the null hypothesis than it would be like 1 to 2? Or is that just because the 0 is not in there, you can just fairly
yeah you only conclude based on the 0. So what you're saying is that if you would have a wider confidence interval versus a smaller interval, yes, if you have a smaller confidence interval, you're more certain of your expected of your indirect effect, but you still make your decision on the basis if it includes or doesn't include null.
Right. Okay. Thanks.
Yeah. Very good. Good point. So there are a few of these effect size measures. So we have the indirect effect, the partially standardized indirect effects, and the completely standardized indirect effect. And the standardization method indicates makes it a bit easier to interpret, because the beta coefficient of 3.4 it also is determined by the scale at which you measure, so an IQ scale with a mean of 100 and standard deviations of 15 is a different kind of scale than when you use, for example, some measure on a 5-point Likert scale, so because the variation is much smaller. So that will determine the slope of your regression model. So to make it more interpretable and comparable to each other, there are some standardization steps that are taken. There were more of these effect size measures in previous versions of the process package. I'll go to my slides in a sec. But even for the standardized effect. Indirect effects, the trick with the bootstrap method is still the same. So we see if we partially standardize, we have 3.8. If we completely standardize, we have 0.69. But we still always look at this bootstrap method to see if it overlaps or not, to determine if there's a significant effect or not. Okay, going back to my slides. So you should be able to calculate a few of these effect sizes. So of course the calculating the indirect effect is simply multiplying the beta coefficients. But if we want to calculate the indirect effect partially standardized, we essentially do the same. We multiply the A times B, but we divide by the standard deviation of the outcome. So if you do that, you are, in a sense, partially standardized, because in the regression model you see that A is a separate regression model in that sense, and so what we're doing here is that we're standardizing only on the outcome, and you don't take the standardization essentially of the predictor variable into consideration. So the fully standardized indirect effect is essentially the same as we did in the previous step, but now we'll be multiplying this by the standard deviation of the predictor variable, and that makes it the completely standardized effect size. Field in the book also talks about the calculating the P of the model. Anyone, any idea what this would stand for?
Is that the ratio of indirect effect to the total effect?
Yeah, so you see that it's not dividing by a standard deviation, but it's dividing by C, and C was, what was it? It was the total effect. So indeed it is a ratio of what is explained by the mediator in comparison to what is explained in total, essentially. So indeed we see this as a ratio, a proportion, not a ratio, a proportion, and that's why it's called a P of the model of the mediator. What is the proportion of the mediator, the effect of the mediator, the indirect effect, to the total effect proportion? So it's about 0.72 in this case. Hayes took these out of his analysis, but I think it does give a bit of an insight in the way you can think about what is explained in total versus what are the components that the mediator covers versus the total model. So we have another, and this is called R instead of P. So this indeed is more like a ratio, right? Where you can have the C accent was the direct effect, so how much indirect effect is there versus the direct effect. And of course that is also an interesting value, because you can say, well, if I have more indirect effect through the mediator than I have through the direct effect, then it will show you that the mediator does something more than the direct effect has. So it shows you, if it's a higher value, it's more in favor of the mediator. Well, it's where it's when it gets lower than 1, it's more in favor of the direct effect. So in that sense, it's a measure that gives you insight. And the last one also covered in the book. No, there's one more. It's looking at the R squares. So how much variance is explained by the model where you only have where you put in both the mediator, the outcome and the mediator. Sorry. If you look at the total effect in essence, so the relation between the mediator and the outcome. Sorry, I'm now confusing these two. You have the relation between the mediator and outcome. That can have a certain amount of explained variance. You can look at the difference between how much variance is explained by the multiple regression and taking out the explained variance part of the predictor with the outcome. Then you're left with a certain amount of explained variance. And if you subtract that, then you have an indication of how much explained variance is left if you take the combined explained variance out of the equation. So that is a different way of looking at what the effects of mediations are, because you could, instead of using the beta coefficients, you could also express this in terms of explained variance, and this is one option that is covered by the book. That is done here. The final one, which was very popular, but it's taken out, it was kappa squared, and where there were so much complaints and issues with it expressed by Wen and Fan in 2015 that it was taken out of the equation. And I'm not sure if Field still has this in the book, but you can absolutely disregard the kappa squared. For interpretation
Question for the exams, what effect?
Sorry, again.
For the exam, which effects are relevant?
Well, it's not a sense that which for the exam which effect are relevant. I want you to know to be able to calculate these effect size and to be able to logically interpret these effect sizes. Again, I won't ask questions where I give you the results and try to ask you give the effect size and then you have to choose. No, I will always, just as the previous exams, be explicit. So I could ask you, well, what is the RM value for this for effect size value, and then I give you the beta coefficients and the things, and then you have to calculate it. Or I could ask you, well, what does the RM stand for in terms of what it means? So
Okay.
those kinds of questions could come back.
Maybe one additional question regarding the explained variance. You mentioned, but here you put for R squared you put. I don't understand. You put output first and then mediator. It's the same thing, right? As putting mediator and output. It's just weird because the output is first.
Yeah, so what it means is that this is a model, a regression model, where you predict the output based on the mediator. This is a regression model where you predict the outcome on the so
predictor and mediator.
Yeah, exactly. And let's see, I can be a bit more explicit, I think. No, okay, yeah, that's it. Yeah.
Okay.
Okay. Any more questions? If
I
not,
might have a question.
Go ahead.
So in the output you had process, you said that the indirect one should be calculated. No, you should just look at the indirect one by looking at the confidence interval and looking if there's a zero in it or not. But for the other one, so the total one and the direct one, we just look at the P, right, and not the confidence interval.
Yes, you have the
we don't see the slides.
Oh, sorry. Indeed. So you with the total effect and the direct effect, you can determine based on the p-value. You do have a lower limit confidence interval, but that's not a bootstrapped method. So it's just the confidence interval around your t-value. So.
Okay, great. Yeah, I was looking at the confidence intervals of those two, and I was like, there's no zero in it.
Yeah,
so
exactly. It's
Yeah. Okay.
Good
Thank
question.
you. I get it now.
Okay. I'll wrap up. I'll stick around for some additional questions if there are any, and I wish you the best of luck. And I'll see you tomorrow in my last lecture. Wow. Okay. Bye, everyone.
Thank you. Thank you so much.
You're welcome. Bye.